Well, it's Sunday, I need to get through the backlog. So it's not a Sierra Hotel 1 Tango set, it's a customer set. And it's a Kernow Beta 2100 GTL. I think this is the other version, I think there's another version. So this is the PR27 version. So it isn't the CB27 early one that... there we go, let's see, the set's powering up. I've not tried it on transmit. Possibly some stretched coils. Disturbed trimmers because of the wax. So it's an 80 channel set. So he wants it optimizing for 80 channel use. So we'll do it on channel 1 rather than channel 20 of the UK set. Or conversely, we could do it on channel 40 of EU, but it's I think it's easier for me to do it on UK set of channels because I can remember the frequencies I can on CEPT as well. It's 27405 for channel 40. So I've just come out of church number 2. So I'll power it up, 13.8 volts. It's got a standby current of 20 milliamps. So bear that in mind if you've got one of these. Flatten your battery eventually. Lovely condition. I don't even know that I've seen this version. It's got the factory original mic with it. It's a 6-pin mic. And it's one of these annoyingly comes on channel 9. On the UK set of channels. So what we'll do it everything on channel 1 instead of channel 20. Don't know the date. I know it's Sunday. Probably about the, I don't know, let's guess, 25th. So what's the date code? Always difficult to read on these. 145 20628. It's one of these sets which has an external socket for an external S meter. It doesn't have PA. So straight away, let's put picture in picture on and let's see what it's doing on transmit. .8. So we're going to do channel 1 CEPT, channel 1 UK, channel 40 UK, 2.8. So chances are that it's going to be less on channel 40 2.8 the same, and chances are it's going to be more on CPT channel 1. It's easier to generate those frequencies. You know what? It's 2.8. It's called me a liar. So it doesn't have low power because it's not 2781. And our transmit current, we'll go back to channel 1 of UK. Our transmit current is still building up. 920 milliamps. Deviation. Now I have to reset this. Wallow. showing 1.5. I'll verify that with the other test set behind me. We're not going to do the VCO. Frequency at this stage we'll take with a pinch of salt because I only put the gear on 10 minutes ago. It should be 27,60125, so it's slightly high, which is ideal, but it'll probably go up a bit. I tend to find that as everything warms up. So let's put that on the signal generator. 27,60125. There isn't actually an extra fee for 80 channel. We'll just have it set slightly high so that it's fair. So channel 1, and now we can hear it coming through with a 10 microvolt signal. So we'll put the SINAD meter on, see what it's doing. Oh, I'll plug the extension instrument speaker in so we can actually get a reading. It's very good actually. In fact, it's so good I'm going to have to check that we've got the switches in the right position. Yep, we have. Well, so we've got 0.23 for 10 dB. 0.21 and for 20 0.62. Squelch. We'll turn that to full. I'll just show you the attenuator rather than the SINAD meter. So we've got 1 microvolt. I want it to open at 100. There isn't a hard and fast rule about this. That's how I want it and what's best from experience. So 1, 3, 10, 30, 100. It doesn't open at 100. In fact, it never opens. So on full squelch, you cannot talk to this radio. So the golden screwdriver's been at that one. So I've set the squelch to threshold on the radio. Put the signal generator on standby, put the signal generator back on. See when it comes in. 1.2 microvolts. Actually not too scary, but I like it to be 1 or less. But that should improve. So does it have any meter at all? So back to transmit. It does, it has a full set of bars. We'll unplug that. And on, let's look at S9 and see what it says. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. It's 6 bars. You know, what is S9? You know, that's probably it. Don't know if this lights up. It does, it's lit up. I think I had a 3100 later version in a pickup truck, and the EU UK is on this mic, and I was forever putting it in the wrong thing. Why is nobody talking to me? And I was on the wrong band. I don't think we're testing the S meter socket. I sold my S meter, didn't I? And then I got a replacement and it arrived broken. Right, well that's got through it, so we'll open it up and see what we can do. So it's brilliant receive, virtually spot on frequency, but the transmitter leaves something to be desired. expect the board's recognisable from some Midland model of the same era. Certainly had an ingress of moisture at the back. So what's that do? Because it's PR2797, we've got receiver specifications. There's a minimum acceptable receiver specification, and so these are crystal filtered as factory standard. This is something you'll get on European, so this is for, I'm saying this now to viewers outside of the EU, or outside of Britain, since we're not in the EU, but you know what we mean. Like in America, where we have minimum receiver specifications since '94. I just want to know what that is. Absolutely no idea. Because it's an FM only set, so I would have otherwise said, well, perhaps they've, with it being an FM only set, the board was normally an AM FM set, and the speech processing was possibly done for the AM side of things and then modified for FM. But in fact, this doesn't have any space for a modulation transformer, so it's it's a pure FM board. So we've got the reference crystal, which is 4.5 because it's CPU controlled. We've got a JRC version of the Motorola MC3357, so it has its own 10.24 reference, and then we've got two crystal filters. There's no sign of any dodgy capacitors. I can see what he says about the stretch, but that might be how they've achieved the power. So I don't know. I've no idea what's what on this. I might look it up, and that's what I'm going to do right now. See if I've got any information on this version. Right, so it looks like we've never had a Kernow 2100 GTL before. So I've got no instruction book, and I've got no circuit diagram. So I can see where all the adjustments are. It's guessing the presets, but it doesn't matter if I upset anything because I've got the test gear to put it back right. So we'll start with the transmitter. So we've got a preset down there, which looks like VR4, VR1, VR2, VR3, VR4. That's VR5. From its position, I would expect that to be power. But you know, you just don't know. So I'll do that right now, making sure we're still on channel 1 UK. So we've got 2.8 watts. It just happens if I just turn that, it is its power. So what we're going to do, we pop that up to full while I tune it. Got to be quick because it won't be able to dissipate the kind of heat it will generate. And with it not being my set, I'd rather not pop it. So we'll go on to the other range. See about this. Yeah, that's the final way they must be aligning it. It's exactly 4 watts at that. Now I don't like it at full pelt, so what I'm going to do is just turn it down a fraction. You've got a point where you're turning, this happens with nearly everything, you're going so far and then it makes no difference. And so, it's like having the wrong gear on your car and you're going up a hill and it doesn't matter how much you put the accelerator down, it makes no difference. It's going to use more fuel, but it's not going to make any difference. And so I need that at the point at which it starts to make a difference. So it's not at full, but it is at full, if you understand that. So we've now got 4 watts. So let's look at the other channels. Four watts. EU. It slides up over a number of seconds. It's interesting it does that. I'd go as bold to say 3.95 watts. And back to channel 1 UK. Doing 1.17 amps now. I think we'll do the deviation right now. But you know what? First of all, I need to find which it is. Voila. So, where is it? Well, from experience, I've got a sneaking suspicion that it's that one. What? It is. Right, I'll just leave it there, which is now reading 2. We'll plug it into the test set behind. I'm wearing shorts, my legs have stuck to the vinyl seat of this chair and then lifted up the seat of the chair. Should have the air conditioning on in here. Swaps glasses so I can read this instrument. Whoa. It could be slightly too high now, so I'll just pop that down. Whoa. Wally. Good. So we've got that, we've done that. So if I jot those down. So VR5 was TX power and VR4 was deviation. So we're going to have S meter, and although it reads a full set of bars, it would be nice to know which one it is. So chances are, yeah, it's unguessable. It isn't that one. It isn't that one. It is the final one. So we're going to set that to a full set of bars the same, but only just a full set of bars. So although it's going to still say full on here, it has been reset. So we know it was 6 bars before, so whatever I've upset, we know the squelch was wrong, so I might have messed those up, but it doesn't matter. That is now 2.2 to a peak of 2.5. We'll do the frequency now, so I'll take the cameras over to that. .60139. I thought it would pop up a bit, and it has. Actually, it's a nice quality trimmer capacitor, that. Except that doesn't fit. Now they drop with age, so you know it's been golden screwdrivered. Keeping it very slightly high. Check our signal generators still about on the right frequency. We'll just bring that down a bit now. I'm going to find the detector. It's one of these sets which is noisy when the volume's down because of cheap transistors. It isn't faulty, it's the way it is. The other day when we were doing that Midland, that is how they are, but it had a fault as well because it was bubbling under the noise. So I want to show the oscilloscope, so I'll switch the oscilloscope on. And we'll do the detector. Why isn't it? Oh, because I've unplugged the. I had to unplug the extension speaker. So we know that these are that's going to be the front end. That's going to be the IF because it's by the 10.695 crystals there, which are the filter. This is the 455 filter, so we know that a coil round there is going to be the detector. So you've got an FM chip, you've got the 455 filter, so chances are that is going to be the transformer we're going to adjust. It actually wasn't right. Now, this might mean that it was that when we come to retest it, it's less sensitive than before, but at least it's correct. Because sometimes you can end up with this being mistuned, but the the receiver looking like it's more sensitive than it really is. So that is something which wouldn't surprise me now. But it would be now louder on receive and more rounded and less distorted. Right, so now we'll go over to the SINAD meter and we'll go through the front end. So we want about 4 dB on there so we can actually see something happening. Very, very slight changes. Certainly been properly done. Bit more signal. We'll do these IF ones. That's not been touched. I'll have to come back to that because I need it elsewhere. Came back, I did a photo. So we can see the transmit line up down there. Transmit power, deviation, just a little there. RF meter, frequency, that's the VCO we're not touching. And we just need to determine these two. One's going to be S meter and the other's going to be squelch. We've got that coil still to do. It looks like we've had the power off in this room because the test set's gone off. Right, let's put that away. I'll have to reset the signal generator. Right, so we're back on frequency. We've just got this one coil to do. Just remelt some of those. Right, we'll read off what we've now got. So for 12 dB, we have 0.25. For 10 dB, we have 0.21. And for 20 dB, 0.55. So we've got it. We've got some of the noise gone. Looking at those figures, our 12 is slightly inferior, but because we've got the detector right, our 20 is better. So as I said, that can easily happen. It can actually make quite a difference, more than that. We now need to find the S meter and do S9. So with 100 microvolts on the test instrument, we should have a full set of bars. Now, of course, I fiddled with it, didn't I? So it's probably going to be that one. It isn't. So, you know, I've gone through them all, haven't I, now? No, it's not that one either. So it must be that one. Don't tell me you've only got one. You have. So it's not S meter at all. That is meter full stop. It affects both. I just find that bizarre. I'll just double check, because it might be that the other one goes to the external S meter to calibrate it that way. No, it does. It does do that. So you've got to set RF meter first, but check you somewhere within for the S meter. So meter brackets RF, S meter, but they are two. They're both linked together. They're interactive. So finally, we'll look at squelch. So I'm going to turn the squelch to full on the radio, and it's squelched. Now, of course, I fiddled with that. Let's put this up on the inset picture. Let's put the inset picture on. How long's that been off? I didn't turn it off. So what have we got? So it needs to come down. That's now opening at 100 microvolts, exactly as I'd like it to. So let's look at the other end. I'll turn the squelch down, turn the signal generator to standby, park it at 0.3 of a microvolt, set the squelch to threshold, switch the signal generator back on. So it's 1 microvolt. It's fine. You know, the mic works, the speaker works. We've reset that at 7 bars, I think it is. But it's neither here nor there because it's not properly calibrated, is it? And we've discovered what does what. Just for my notes, VR1 was squelch, VR3 is RF meter, and this one is on top of the writing, so that must be S meter. It's the only one left. There we are. I was going to say it's unusual to have a preset for the external S meter because that has its own preset. So we'll pop that together, and then on the air test will follow quite shortly. I think we'll change some of these screws which were rusty. See if we can find any that aren't rusty. Now I'll put all new ones in. So it works nicely, this, and I'm sure it's going to work nicely on the air test. You know, people are going to look at this and go, oh yeah, it's just one of those rubbish 90s sets, and you know, it's crystal filtered because it's after the time when any old thing went. I think about the worst sets were the Giessen ones. I'm not saying they all were, but there were some low in the range ones which were so badly made, and I think the early team ones were as well. But this goes past that era. Alright, put one more screw in that. And I'll make sure I note that we've put 4 screws in so we actually charge. I think they're all of 6p each. There we go. So it's 80 channel and 4 times screws. Right, turn the test equipment off. I really should have put the air conditioning on in here, but for once I can hear thunder now. For once I didn't because of the noise. But if it's just hot tomorrow, it's been 29 degrees out. I've got living room air conditioning on and back room the one which Mr. Chippy uses as a workshop. Okay, so there we are, channel 1. Oh, what's that do? Oh, it's got, if you press that button, it's got like a, I'm not going to say modulation meter because it's deviation, isn't it? But 1, 2, 1, 2. How interesting. You see how thrilled I am? I suppose it's useful if you didn't think your mic's working. 190 Roger. You have to wait for it to do anything, half a second between channels. You can tell we're getting onto newer sets. It's not a real channel selector, it's just a rotary encoder, so it just does what up down would do. See, we've got a pile of interference on EU. On the air test, we'll flick it to EU at the 5 mile point. Nineteen Roger. Dead as a dodo on there. I'll leave it on 19 and we'll come back to this. I think we'll be doing the on-the-air test within half an hour. So we are, a set I've never seen before. The Kernow Beta 2100, but the GTL 80 channel version. Thanks for watching.